Okay, color ratio. What is what we call writing? Ratio, like that. Guys, color ratios, thank you. Actually, it's short for these complementary ratios. Do we remember what complementary means? The two angles of complementary, what do they add up to? 90. Supplementary is 180. Complementary is 90. Actually, I'm not sure if there is a word for 350 actually. Yes, supplementary is 180. Yeah. So complementary is add up to 90. Guys, I don't know if you noticed when we were doing reduction formula before, we just looked at 180 and 360, right? We didn't look at 90 degrees at all. So again, I wanted to just to draw a little Cartesian plane. And now we're going to add in some angle measurements here. I'm just going to put in my quadrant, 1, 2, 3, 4. Row our course, right now. Okay, now we say that this was 0 degrees, this was 90, this was 180, 270, and then 360 as well. And then we said that if I give you an angle, let's call the angle theta, that represents an acute angle, so that is always in the first one, right? Remember that? We did it all time yesterday, so we should remember that. And then in quadrant 2, what kind of angle is in the second quadrant? If we're talking about reduction formula, it was always 180 minus theta, right? Or x, yeah, we're using theta for this one. So 180 minus theta. But guys, what about 90 plus theta? That will also actually give you an angle in the second quadrant, right? 180 is there minus theta, that lands up in the second quadrant. But we haven't looked at what happens when you have a 90 degrees plus an acute angle. We agree that that's also in the second quadrant, right? Because 90 is there, and then theta, you're adding an acute angle to it. So 90 plus theta is also in the second quadrant. And that is what we're going to talk about today. That's where the color ratios come from. Whenever we're working with a 90 plus. Now guys, in the first quadrant, we can also write, instead of just working with theta, because we had other expressions that got us in the first quadrant, right? You guys remember like 360 plus theta. I think that maybe even came up in the text, right? 360 plus theta, that's first quadrant. Okay, but now because we're looking at 90, we could also say 90 minus theta. That will also give you an angle that's in the first quadrant, right? So you're going from 0 to 90, and then you are subtracting an acute angle from it. So 90 minus theta can also land you up in the first quadrant. Now I'm just going to write for the third and fourth quadrants. We know for quadrant 3 we use 180 plus theta. Now guys, we could say 270 minus theta, but that's not in the solution. Okay, I'm going to write it in here, but we're not going to use it. Okay, but if you're going from 0 all the way to 270, and then you are subtracting an acute angle, that will land you up in the third quadrant as well. But like I said, we don't actually need to be able to use that one, but that will also be a correlation. All right, and then how could I use 270 to express an angle in the fourth quadrant? Plus theta, good. So I could say 270 plus theta. Again, the 270s Those are not in the syllabus, so you want to do a question with those. But just for the sake of completeness, right? What other angle would give us positive 4? What are we going to do? Minus x or minus theta in this case, and then there's one more. 360 minus theta. Hey, that also lands up in the fourth part. Okay, those are just the most common ones that we've seen, but obviously there are lots of other ones that would also be. Okay, so guys, just make sure that you've highlighted, especially these two with the 90s and then these two with the 270s, because those give us correlation. Okay, so if you see the word correlation, I want you to think immediately 90 degrees. 90 plus, 90 minus. Now, just like we did with the reduction formula, first I'm just going to do some numerical examples so that you can see kind of like a pattern. So we're going to look at sine of 30 degrees. I think this is also what we used for the first reduction formula, right? Can anyone remember what sine of 50 was equal to? It was a half, 1 over 2. Guys, the interesting thing is that cos of 60 degrees, right? Again, you could use a special triangle here if you wanted to, but if we just use a calculator, cos of 60 is also a half. Now, what is the relationship between 30 and 60 degrees? They add up to 90, hey? Didn't we say that that's what complementary angles are? Angles that add up to 90. So I'm going to write here 30 degrees and 60 degrees are complementary angles. That's what we call them. Because 30 plus 60 is equal to 90 degrees. Now guys, because these two are equal, right? Can you see they're giving the same values? And because the two angles are adding up to 90, we call sine of 30 and cos of 60 correlation. Okay, we are going to look at more of them to demonstrate. But just for now, we'll say sine 30 and cos 60 are correlation. They're equal to the same values, and the two angles add up to 90. Now guys, instead of writing cos of 60, we actually could have written cos of 60 in a different way. Remember when we did the reduction formula before? I'm just going to go back to some previous pages with you, so bear with me. When we looked at these reduction formula, when we had sine 30, then we looked at sine 150. But I wrote 150 as 180 minus 30, right? So I used the original angle of 50 degrees, and I said, what do I get when I do 180 minus 50? Okay, the first angle was 50. What do I get when I take 180 minus 50? Now we're going to do the same thing here, guys, because do we agree that cos 60, I can write that. Sorry, I can write that as cos of 90 minus 30. Isn't that the same thing? 60 degrees is the same as 90 minus 30. All right, do we agree with that? So I'm just rewriting 60 in a different way as 90 minus 50. Guys, what was this equal to? Cos 60 was also equal to sine 30, okay? They were both equal to a half. Do you guys see what I'm doing? I'm saying that cos 60 is equal to the same value as sine 30. which will equal to a half. Now, I'm sure you'll notice a pattern when you do more examples, but just for now, you can just circle that 30-degree angle in the brackets there and in the 30 that we use at the bottom. Okay, we probably confused at this point, don't worry. We're going to do more examples and then we'll see what we're going to do for this. But guys, what I want you to see is that cos of 60 is the same as sine of 30. Right? And what is the relationship between 60 and 30 again? They add up to 90. Okay, we're going to look at some more examples quickly. Let's do sine of 10 degrees. We're going to calculate that. So guys, what is the complementary angle of 10 degrees? What angle do I have to add to 10 to get 90? 80. So I'm going to check for cos of 80, because isn't that what we did in the previous question? We looked at sine of 30 and then we looked at cos of the complementary angle. Right? So let's see if we get the same answer for these two. Sine of 10 is 0.17. Then cos of 80, right? So we use cos for the other one, and we do the complementary angle of 10 is also 0.17. Right? So I can see that sine of 10 now guys, again, just so that we can see the 90 minus thing, I'm going to rewrite 10 as 90 minus what will give me 10? 90 minus 80 will give me 10. And that was equal to what had the same value as sine 10? Cos 80 degrees. So again, guys, just like in the previous example, 10 I rewrote as 90 minus 80. And then, instead of writing 90 minus 80 for the next one, I kind of dropped the 90 minus. I take the 80 degrees that I added to cos. Right, so I take cos of it. The other one, cos of the complementary angle. We're going to do one more and then we're going to write the generalized form of this, okay, because we mostly use the generalized form. So we do sine of 20 degrees. Now, what do you think is going to be equal to sine of 20? Because I've seen it. Good. So we take the other one, cos instead of sine, and we look for the angle that I have to add to 20 to get 90, which is 70. I'm putting in a typo. In sine of 20 is 0.34. And cos of 70 is also 0.34. Okay, that is what we expected. So now I'm going to write the cos first. You can do it in any order, right? You can start with sine 20 and change it to cos 70, or you can go from cos and change it to sine. So I'm going to go backwards this time and say cos 70 is the same as cos of 90 minus 20. Right? Do you guys agree? 90 minus 20 is the same as 70. So here I haven't actually changed anything yet. I'm just writing 70 as 90 minus 20. Okay, but it's all the same thing that I've written here. Now, what is my acute angle in these brackets, guys? The acute angle is 20. So now I'm going to change cos to sine, and I'm going to drop the 90 minus, and it's going to be sine. Because we saw already, right, that cos 70 is actually equal to sine 20. I understand that. Okay, so from this, if you have the sine of 90 minus x, now instead of an actual acute angle, I'm using x, right? If you remember that x or theta always represents an acute angle. Just add that to it, okay? Now guys, can I say that this is equal to sine of x? What if I change the sign to? Check what did we do at the top there? We started with sine of 10, we changed it to cos of 80. So sine of 90 minus x, we're going to have to change to cos of x. So the acute angle in your brackets, you again are just left with that angle. We drop the 90 minus, just like we dropped the 180 minus and the 180 plus before, right? But now the difference is, guys, if there's a 90 in your brackets, you have to change sign to cos, right? Otherwise, they're not going to be equal. Because if you have sine 10, that's not the same as cos 10, right? But sine 10 is the same as cos 80. Okay, so that's why we have to change the sign to cos. And we're going to do the same thing if we're working the other way around. If we're starting with cos of 90 minus x, you see 90, you must think immediately correlation. So change cos to sine. Okay, that's the important thing here. So we're going to change it to sine, and what is the acute angle that I have in my brackets? X. So it's going to become sine of x. Okay, well guys, cos has to change to sine, and sine has to change to cos. Right, the good news is there's no tan when it comes to correlation. All right, it's always going to just be sine and cos. So sine will change to cos, cos will change to sine. We just quickly need to look at what happens with 90 plus x, because we haven't actually looked at that, right? All of these were 90 minus. So are we okay with this now, right? And the way that they're going to test it is just like the other reduction formula, right? You'll get a reduction formula question, and one or two of your brackets are going to have 90s in them. Okay, so just like we did for your test, you're just going to have to change this to cos x and then go. Okay, we'll do an example. So guys, when you are working with 90 plus x, it is slightly different because 90 plus x, that angle is in the second quadrant. 90 minus x is a nice one because which quadrant is 90 minus x? Quadrant 1, right? And all the trig ratios are positive in quadrant 1. So that's why I haven't really been looking at signs. Okay, because 90 minus x, that's quadrant 1, it's always positive. So 90 plus x, guys, what is cos? What is cos in the second quadrant? Is it also positive? Negative. It's negative. So just like with our other reduction formulas, we have to take the sign in the second quadrant. Okay, so I'm going to add here, sine is greater than 0, positive in quadrant 2, and cos is negative in quadrant 2. So if they ask you for sine of 90 plus x, just like you do with all the other reduction formula, you need to ask yourself, which quadrant is 90 plus x in? Quadrant 2. Right? What is sine in the second quadrant? Positive. So this is going to become positive, but it's going to be positive sine. What does I change sine to now when there's a 90? Cos. So this is going to become positive cos of x. I'm putting that plus there. You don't usually do that, right? I'm just trying to indicate that because sine is positive in the second quadrant, when you change it to cos, it stays positive. Even though cos is not positive, right? So it's a bit confusing, right? But you always look at what is sine in the second quadrant. It's positive, so I change it to positive. But now cos of 90 plus x is now the one that's different. Again, you'll say which quadrant is 90 plus x? Quadrant 2. What is cos in the second quadrant? Negative. So this now becomes negative. And what do I change cos to? So there's a 90 plus sine. And I'll use the okay, so that's actually the only correlation that will ever be negative, is cos of 90 times 8. Okay, because cos in the second quadrant is negative. So when you change it, when you use that correlation formula, you have to change it to negative. Okay, we're going to apply it now to kind of like a mixed question so that you can see they're going to ask you to do these. Maybe I'm just going to practice some little things. The equation that this one has. Okay, so it is a fraction that I'm just going to write over 2 lines. And so you can see that this is a reduction formula question, right? So normally what I do first is I just write down all the quadrants. So 90 minus x, what quadrant is that? 90 minus an acute angle, that's quadrant 1, right? What about 360 minus x? 4, quadrant 4, yes. Then at the bottom here, again we have 90 minus x, again that's quadrant 1. And for that last bracket, we have 180 plus x, that is quadrant 3. Okay, so again, it's useful if you have your little course diagram on the side, just in case you get confused because there's a lot going on there. All right, just to make sure. So this 2, I'm just going to leave that 2 where it is. Now, guys, what I want you actually, let's highlight the 90 here and at the bottom. Because 90 is like the odd one out, right? 90 is the reduction formula where you have to change the trig ratio to the other one. So cos at the top, I'm going to have to change to a sine. Okay, and what is cos in the first quadrant? Positive, so it's going to change to positive sine x. All right, so we're going to change that to just sine x. So basically 2 sine x is what I have there on that term. Minus, guys, what is sine in the fourth quadrant? It is negative. So just so that we don't forget that second negative, let's put it in brackets. That's going to become a plus, right? Over At the bottom, again, we have a 2 in front. Now, what is sign in the first quadrant? Positive. But sign, because it's a 99, the sign has to change to cos. All right, that's what we just looked at with the correlations. So this is positive cos x. So basically 2 cos x at the bottom there. Minus. Now for the last one, what is cos in the third quadrant? It is negative. So again, I'm going to have a negative cos x in that last matrix. So that's for the 360 minus and the 180 plus. If it was sign, it stays sign. If it was cos, it stays cos. Right, 90 is the only one where you have to change the actual trig ratio. Okay, now that is going to become a plus, and this is also going to become a plus. So what do I actually have at the top there? 2 sine x plus sine x. What's that? 3 sine x, hey? 3 sine x. So there's 2 sine x plus 1 sine x. So 3 sine x. And you guys see that the same thing is happening at the bottom. 2 cos x plus 1 cos x. So at the bottom, I also have a 3 cos x. Now it's 1 term at the top, 1 term at the bottom, so we can cancel out the 3's. And what is sine over cos? Tan. There we go. So the final answer here is tan x. All right, so guys, basically correlations, the same as the other reduction formula work. You just need to remember that if it's a 90, you need to change sign to cos and cos to sine. Okay, we're just going to practice a whole bunch of these because tomorrow we're moving on to working with numbers, not x's and theta. So it is a little bit different, the stuff that we're doing tomorrow. So exercise 9. On page 149. Okay, now there are 8 questions, guys. You have half an hour. Let's see how it goes. All right. If it takes you very long, then I might say you only have to do it first. But yeah, let's see. I'll put the questions on the board and then you can see what they're asking. But it's basically good questions like this. I think the actual reducing is fine. It's more when it comes to like you've reduced and now you must do something else after. Right? So you must change like a tan or sign of a cos, but you must be able to do that as well. And guys, what I didn't mention, I just saw now in the one question they have this angle. Wait, I'll just write it over here. They have beta plus 90 degrees. Now that's not an angle that we looked at. But remember, you need to be able to figure out in which quadrant an angle is, even if it's an angle that you haven't seen before. So what do we think? Beta is an acute angle, right? So beta is in quadrant 1. And now you are adding 90 to it. Do you agree that that's quadrant 2? Okay. So again, they might give you an angle that looks different from what you've seen before, but you need to be able to figure out which quadrant that's in. And again, because there's a 90-degree involved, you must change if it was a cos, you must change it to a sine. Okay, or if it was a sine in front of this, you must change that to a cos. So guys, as soon as you see 90, you must know you must change. Okay. Yeah, just quickly write that down so that I can take the questions on the board. Sure, something over my list. Okay. Okay, there you go. If I zoom in more, then it's very grainy. So just let me know if you guys can't read any of that, and I'll tell you what it is.